Okay, welcome to Chapter 6. We're going to start out with something pretty simple, the Polygon Angle-Sum theorem. And in this, we're going to be able to look at how many degrees are in the angles of any polygon. Now we'll start with the triangle. We already know that these angles are going to add up to 180 degrees. And we're going to be able to use that to figure out how many degrees are in any polygon, because we can split polygons into triangles. So for example, here I have a quadrilateral, so if I draw a diagonal across here, just like we have down here, we can add the number of triangles. We see 180 plus 180 is 360 degrees. Now we might be tempted also to connect B to D. Why don't we connect everything? Well, the reason is that would give us 4 triangles here. Notice it also gives us 4 angles that are in the middle here. We only want to know about the angles around the actual quadrilateral here. So if I look back at this one, all of my angles in my triangles are being added up by adding the parts of these triangles. Looking to find the number of triangles to use, we're going to start at one corner of our polygon and we'll start drawing diagonals, as many diagonals as we can from that one corner. So notice here with the 5-sided figure, a pentagon, I end up with 3. So with my 3 triangles, I multiply times 180 and I get 540. If I have a hexagon or 6 sides, I draw from one corner and that gives me 1, 2, 3 diagonals, which produces 4 triangles. So I take 4 times 180 times 720. So notice here, 3 sides is one triangle, 4 sides I can divide it into 2 triangles, 5 sides I can divide it into 3 triangles, and so on. Basically the pattern here is we always have 2 less triangles than we do sides. And so we can get a formula out of this. We take the number of sides and subtract them by 2 and multiply times 180. If we're asked to find the sum of the interior angle measures of a heptagon, then we need to know first of all how many sides that it has. That would be 7 sides in a heptagon. And so for our formula here, using the angle sum, that would mean that n equals 7. N could be the number of sides, which would also be the number of angles. So we're going to plug that into our formula. Our sum of the angles will be 7 minus 2 times 180, or 5 times 180, which will give us 900 degrees. So any heptagon, any 7-sided polygon, we know that if we add all the angles together, we're going to get 900. Okay, a little bit of vocabulary. Equilateral polygon means that each angle is the same. Equiangular polygon means each angle is the same. Notice this is different than equilateral triangles. In equilateral triangle, if the sides are the same, the angles are the same. But that's not always true with other polygons. We have a special name for one where the angles and sides are the same. So if the angles and sides are the same, it's a regular polygon. So if it's a regular polygon, we can find the number of degrees for each angle. We'll start by looking at the sum of the angles, okay, however many sides, just like we did on the last page. But then, since there are, in this one, say 6 angles, we would then divide that sum by 6, or we would just divide by the number of angles that we have. Notice it's our sum formula from the previous page divided by the number of angles. In this next question, we want to find the measure of each interior angle in a regular nonagon. So we're talking about a figure with 9 sides where each side and each angle is the same measure. So we're going to use our formula for one angle in a regular polygon, where on top of this formula we have the sum theorem for 9 angles, which would be the n minus 2, but here we have 9 for our sides, times 180. We'll then divide that by the number of angles that we have, which here is 9. So the sum of 9 angles, and then dividing by 9 so we know how big each one is, because it's regular and they're all the same. So this one will work out to 7 times 180 divided by 9, which will give us 140. Okay, the next question, we are given that one angle is 108 degrees. So if we look back to our formula here, we were looking for the one angle and then we used our formula. But in this one, we're looking for whatever has 108. We're looking for the angle that has a measure of 108. So notice this is our sum formula, but we want the one angle formula. And so we're going to divide it by the number of sides. We don't know how many sides, so we're going to keep that as n. And then we can solve this as an equation, multiply both sides by n. We can move this over here. That gives me a negative 72n equals negative 360. And then dividing, we get 5. That tells us that this shape would have 5 sides. If it's a regular figure, then we have a regular pentagon. In the next one, we have another pentagon. There's 5 sides here. We can see by counting there. And they want to know the measure of this angle. So basically, we can take all of these and add them together, but I treat this as the measure of angle y plus 90 plus 110 plus 120 plus 150. And that's going to be equal to the sum of all the sides. So we need to find the sum of the sides in this problem. To do that, we're going to use our sum formula again, which was, again, n minus 2 times 180. We have 5 sides, which will give us 3 times 180, which is 540. And so we know that all of these angles need to add up to 540, and we're missing one, so we just need to add these other ones together and subtract. Adding those will get 470, and if we subtract, that will leave us with 70. And so we know the measure of angle y is 70 degrees. The next theorem is the exterior angle theorem. The interesting thing about this one is no matter how many sides you have, if you have an exterior angle and you add all these exterior angles together, they're always going to add to 360. Now just remember, an exterior angle is when we have our polygon, we choose the side and we extend it. So if I extend the side, and then we keep going around in the same direction, extending the sides, and then our exterior angles would be the ones, not the straight side, but the side that's inside there. So if I add all 4 of these red angles here, I would also get 360 degrees. Even if I had 100 sides, okay, those angles are going to get really skinny, but they're still going to add up to 360 degrees. So I might have a problem like this. I have a regular octagon. Again, regular means all of our angles are the same. All of the sides are also the same. And if I want to find the measure of these exterior angles, whichever one, here they're asking for angle 1, but it doesn't matter, they're all the same. I can just take 360 degrees and divide it by the number of sides. Here I have an octagon, there's 8 sides, and that will give me 45 degrees.